Hello, my name is Alex Krotz, and I'm going to be showing you my PTI PL2300 nitrogen laser, which I modified to function in normal atmosphere. or I didn't make too many modifications, rather it was just an adjustment of the spark gaps. First, we can go over the circuitry. This is what's called a TEA laser, transverse atmosphere excitation. Transverse excitation atmosphere laser. And inside, I'll take the lid off in one moment, but we have this circuit, which has a set of 24 capacitors in total. The circuit is doubled. And two spark gaps. You can see spark gap 1 and spark gap 2, as well as a high voltage input, a ground, two 200 kilo ohm resistors, a small inductor, and an input pulse of, moderately high voltage, about 1 kilovolt, I think. Anyway, and then you have two transverse electrodes which excite the gas in between and then produce the laser beam. So spark gap 1 functions, or the way the triggering mechanism works is that we have this outer electrode with a hole in it, and then this secondary electrode, and then the primary electrode is this pin. And so when the capacitors are charged and this PWM signal comes in and sparks across to this pin, it creates a low resistance path for essentially the charges on this rail and the charges on this rail to combine, and essentially bringing the net charge separation on this capacitor to 0, or on these 4 capacitors. That in turn causes a surge of charge from this side of the capacitors on the outer 2 rails, which will in turn cause spark gap 2 to go off as it pulls electrons from there and through the electrode. The lasing process is just the normal nitrogen laser excitation. So you start at the ground state and excite it to this very short-lived triplet excited state. I calculated a 3.54 nanosecond lifetime at atmospheric pressure, and using atmosphere, not pure nitrogen. Then you have a fast emission of a photon at 337.1 nanometers to this next excited state, again a triplet, and then you have a relatively slow decay to a metastable triplet state, and this has a wide range of lifetimes that's believed to be temperature dependent, I think, and then it can either remain in this metastable state, or once its lifetime has completed, it relaxes back to the ground state vibronically, or vibrationally. So then we'll open the laser and see how it works. So you can see here, this is the first set of 12 capacitors. Those black pins are how I adjust the spark gaps, so pushing them in or pulling them out will change the distance between the gaps. The electrodes. This is spark gap 1. And you can see that coil is what generates the high voltage input to the spark gap. And then this is spark gap 2. It's much larger and much more robust. This on top is the timing and control circuitry. The blue thing is the high voltage power supply. And then there's just some gas manifolds and pressure gauges and knobs and such. I modified the control panel slightly because the condition I received this laser in was the laser would not function. So I removed one of the light bulbs, replaced one of the knobs, and added this switch of my own. And yeah, the laser seems to be working now. However, sometimes the electrodes get out of alignment and it stops lasing. Okay, let me try it out. Caution, the pump is actually very loud, so you won't be able to hear me say anything, but you'll be able to see the laser beam on that yellow highlighter dot over there. So yeah, I forgot to mention that I do have a small lens from a telescope fitted onto the output of the laser, but other than that there are no optical components. Well, that and a mirror on one side or on the opposite side of the electrode gap. Yeah, hope you enjoyed this video. I'll probably do a disassembly of the spark gaps so you can see how they work on the inside better. Until then,